lesson 4 looks at solving logarithmic equations. So we looked at solving exponential equations using logs, but now we're looking at actually solving some of these logarithmic equations. There are several ways that you can approach these questions, but really you're going to be using your law of logs, so you're going to be using your formula sheet, and really what you want to do is you want to get to two possible scenarios where you have a log of the same base, simplified, one log on this side, one log on that side. If the bases are the same, then we can make the assumption that P has to be equal to Q, and then we can continue solving. Or we have a single log on one side and a value on the other side, which then I can write as an exponential equation and then continue solving. So what we'll look at in this lesson is just solving various examples and going through and looking at what the solutions mean. So Alice is solving the equation log 5 of x plus 1 plus log 5 of x minus 3 equals 1. Part of her solution, including the explanation, is shown below. So she starts off with her question. Then in the next step, she uses the product law to combine these two logs. The bases are the same. I'm adding them, so the product law says that I can multiply them. Then at this next step, she rewrites this into exponential form because I have a log equaling a value. So 5 to the power of 1 equals this expression. And then from here, we're at the quadratic solving that we did last year. So it pulls some of the stuff that we learned last year to continue through on the solving. So if we complete this solution by solving for x, I would expand this left-hand side. So when I expand the left-hand side, what would I get?
X squared minus 2x minus 3.
Good. So x squared minus 2x minus 3 would equal 5. And then what would I have to do? Move the 5 over. Because when I move the 5 over, I now have a quadratic. And to solve quadratics, we look at two main ways. We look at, can I factor it? And if I can't factor it, can I use the quadratic formula? So can I factor this quadratic? Two numbers that multiply to negative 8 and add to negative 2.
Negative 4 and 2.
Negative 4 and 2. So what are my solutions for x? What can x equal?
4 and negative 2.
4 and negative 2. Now, if we try to verify this, so we put these values into the equation. So if I start off with my 4, I get log base 5 of 4 plus 1 plus log base 5 of 4 minus 3 is equal to 1. So what is 4 plus 1? 5. So I get log base 5 of 5 plus log base 5 of 1. What is log base 5 of 5? 1. And what's log base 5 of 1? 0. And what's 1 plus 0? 1. So does the left side equal the right side? So this one checks. So now if I look at the next one, I get log base 5 of negative 2 plus 1 plus log base 5 of negative 2 minus 3. So negative 2 plus 1 is what is negative 2 plus 1? Negative 1. And negative 2 minus 3 is negative 5. What is log base 5 of negative 1? So log base 5 of negative 1 would be log negative 1 divided by log 5. What do I get? A non-real answer, meaning that it's not possible. I can't take the log of a negative number. We looked at that in the last chapter. So at this point, this is not possible. So the only solution that I can actually have is that x equals 4. X equals negative 2 is no longer a solution. And then finally, in solving this equation, Alice arrived at one of the two positions shown in the introduction. Which position did she arrive at? Where I had a log on each side, or where I had a simple log equaling a value? Right here.
Simple log.
The simple log. She arrived at the second position. Right there. Okay. And then on the next page, it goes on to talk about that solution of negative 2. Even though it's a solution to part of the question, it does not fit into the original question. So logarithmic expressions are only defined for positive values of the argument. So in this case, the value of x equals negative 2 is an extraneous solution. So it's not the fact that x itself, it's not that because x is negative, it's extraneous. It's because when I put it into the question, I get an extraneous root. So you can't just automatically eliminate a negative value simply because it's negative. It gets eliminated because when I put it into the question, I get the negative argument that I can't use. Because it could be a situation where a positive number, when I put it into the original equation, could be an extraneous root. Okay? So a logarithmic expression is defined for only positive values of the argument. That's an important thing to remember. And when we solve a logarithmic equation, we have to verify that that the solutions do not result in the log of a negative number. Because then if they do, I get this extraneous solution and it's not valid. Values obtained by solving log equations may be extraneous and have to be verified. There are two verifications required when the solution is placed in the original equation. If all the arguments of the logarithm must be positive, and if the base is a variable, so if it's the base that I was trying to solve for, I have to make sure that it is positive. Okay, so if I go to solve the next question, I've got the same log, the same base, so I can look strictly at the arguments. So I get x squared equals 16, and how do I finish solving this?
Both sides.
And what do I get? X equals
4.
Okay,
Positive, negative 4.
positive or negative 4. And then if I go to verify this, I get on the left-hand side log 4 squared, which is log 16, which equals log 16. So that works. Or I get log negative 4 squared, which equals log 16, which equals log 16. So I verified that both answers work for the first one. Now if I look for the second one, 2 log x equals log 16. As you guys said before, I can bring the 2 up to the exponent. Now I've got the same base for my log, so I can let the arguments equal each other, which gives me the same as what I got over here. But now when I go to verify it, so I get 2 log 4, oops, got the 2. Then when I put the 2 up, I get my log 4 squared, which equals my log 16. That works. Then when I put my next one in, I get 2 log -4, which is a problem. This is not possible. So the actual solution to this equation is that x can only equal +4. X cannot equal the -4. Because in the original equation, 2 log -4 is not possible. So now when I go to graph these, if I graphed, did you guys graph them as intersections or did you graph them as one equation? Intersections. So then the graph that I would get, so I would get this line that goes through 16, right? Correct? And then I get these graphs that look like
should
that.
be through like log 16, so it should be lower.
Oh, right, yes.
Since it was not like scale.
Yeah.
Can I see what you guys drew? Because mine just drew it a little bit different.
I just did it as one equation.
You did it as one equation? Okay. So, right, your log 16 still gives you a straight line, it's just not necessarily as high. And these 2 equations, they do follow that format. I know on your graphing calculator it kind of makes it look like it's that shape, but I want you to show that there's a break because it does not cross that y-axis. Okay? And then when I graph this side, I still get my log 16, but my 2 log x gives me that half. Okay? So it says that, or in question C, says explain why the solutions to the log equations are not the same, even though 2 log x can be written as log x squared. The reason why they're not the same, we go back to domain. The domain for log x squared is that x can be anything except for 0. It's the only thing that x can't equal. But in this case, x can be negative because I have to square it before I take the log. Whereas the domain for 2 log x can only be the x values that are greater than 0. Because I cannot have a negative argument for my log. Okay? So we're going to continue solving logarithmic equations. And they're going to progressively start to become a little bit more complex, and we'll discuss strategies and ways that we can solve these. So if we look at class example number 2, I have log base 4x plus 1 minus log base 4 2x minus 3 equals log base 4 of 8. So if you look at your formula sheet, remember the idea is I'm trying to either have a log equals a log or a log equals some value that I can then turn into an exponent. So which form, let's call this A, and this one B, which form do you think I want to try to simplify this one to? Probably to A, okay? So I already have this done. Log base 4 of 8 is already done. What can I do to combine this together? What can I use? The quotient law. So then I can rewrite this as log base 4 of x plus 1 over 2x minus 3. And now because I've got logs of same base, the arguments have to be equal to each other. How would I solve this?
You could multiply 8 by the 2x minus 3 to get out of the denominator.
Okay, so x plus 1 equals 8 times 2x minus 3. So I get x plus 1 equals 16x minus 24.
And then you could subtract x on both sides.
Okay, so then 1 equals 15x minus 24.
Then add 24 times.
So 15x equals 25.
Then divide by 15.
So x equals 25 over 15. And what can I divide 25 and 15 by?
5
And what do I get when I divide them both by 5?
thirds.
5 thirds. Okay. I want to verify this. Actually, I need to verify this. So I need to put this in. Log base 4 of 5 thirds plus 1 minus log base 4 of 2 times 5 thirds minus 3. And I want that to equal log base 4 of 8. So what is 5 thirds plus 1? Five thirds plus 1 is how many thirds?
8 thirds.
8 thirds. And 2 times 5 thirds? So 2 groups of 5 thirds would be how many thirds?
10 thirds.
10 thirds. And then if I take 3 away from that, so taking 3 away is the same as taking away 9 thirds.
So 1 third.
So it'd be 1 third. I can still use my quotient law. This still would become log base 4 of 8 thirds divided by 1 third. What is 8 thirds divided by 1 third?
It's 8.
It's 8. Which equals the right-hand side, which means I verified it. So that is going to be the only tricky part to these questions, is you have to remember to always verify the solution. So if we look at B, what form do you think I want to get this to? The A form or the B form?
B.
Why B?
Because you can use the log 6 to
Oops, B plus, right? Equals 1. Really, what I have is I have a constant term. That's what I can use my B for. So how do I put this together to create one log?
You can multiply the 2.
Right? So I've got my product law, x plus 4 times x plus 3. And then what would I do at this point?
And exponential form.
Exponential form. So the exponential form would be what?
6 to the power of 1 equals all that stuff.
All that stuff. So x plus 4 times x plus 3 is equal to 6 to the power of 1. Now what would I do? brackets. X squared plus 7x plus 12 equals 6. Then what?
Move the 6 over.
Move the 6 over. X squared plus 7x plus 12, or sorry, not plus 12, plus 6. Then what?
And you can simplify it to x plus 6 and x plus 1.
Okay. X plus 1 times x plus 6 equals 0. And then what does x equal?
Negative 1 and negative 7.
So remember what I said before, just because the numbers are negative does not mean that they're already extraneous solutions. We have to check them. So if we check them, I get log base 6. Let's say if we check the negative 1. So I get negative 1 plus 4, which is if I put negative 1 in here,
Log base 6 of 3. Negative 1 plus 4 is 3.
is 3. Okay. Equals 1 minus, sorry, we don't use an equal sign when we're verifying. We use a line. There we go. Fix that. The log base 6 of 3. And then 1 minus log base 6 of what?
2.
2. If these are positive, am I going to be able to find the values? And I could take my calculator to do the rest of this because it's not something like over here where we could actually figure it out. This is going to be something that's not necessarily going to be nice. So at this point, we can say that we're most likely correct. And then if I look at my x equals negative 6, I get log base 6 of
Negative 2.
and then I get 1 minus log base 6 of,
Negative 3.
and because I've got negative arguments, this is not possible. So this becomes the extraneous root, and x equals negative 1 becomes our solution. Okay, we'll do class example number 3, and that's where I'll stop. So solve 2 times log base 3 of x minus log base 3 of x plus 3 minus 3 to 2 decimal places. So what would you do first?
Move the 3 over to the other side.
Okay. Is there anything else I can do at the same time?
Quotient law?
Before I do the quotient law,
Don't you have to expand? Oh, move the 2 up.
move the 2 up. So log base 3 of x squared minus log base 3 of x plus 3. Then I could use the quotient law. So log base 3 of x squared divided by x plus 3 equals 3. Then what would I do?
Turn it into exponential form.
Okay, and when it's in exponential form, what would that look like?
3 to the power of 3 equals x squared divided by x plus 3.
Okay. And then what would I do?
We know 3 to the power of 3 is 27.
Okay.
So then we can move like the x plus 3 up to the 27.
So I figure this out, and then I multiply both sides by x plus 3. So I get 27x plus 81 equals x squared. Then what would I do?
You can move the 27x and the 81 over to the other side so the equation will just
Yeah, I'm going to make myself a quadratic. So the 27x and the 81 would become 0, or sorry, would become negative, and then I would get this quadratic. And what are the two ways that we try to solve a quadratic?
Factor it or use the
Okay, so factor it. Can you think of two numbers that multiply to negative 81 and add to negative 27? If you think of your factors of 81, there'd be 1 and 81. It doesn't divide by 2. It divides by 3. Not by 4, not by 5, not by 6, not by 7, not by 8. I get 9 times 9. Do any of those combinations give me a sum of 27? So what am I using?
quadratic formula.
Yay! Where I need to move the camera and pan it on you guys. This is what students look like when they have to use the quadratic formula. So x equals positive or negative b, which is negative 27, or sorry, not positive, negative b. So negative of negative 27 plus or minus the square root of b, which is negative 27 squared, minus 4 times a times c, which is negative 81, all over 2 times a. So negative of negative 27 becomes a positive 27. And then negative 27 squared minus 4 times 1 times negative 81 equals come in. He's learning his math. Smart boy. 1,053. So now if I look at my two values, we calculate the first one. 27 plus the square root of 1,053 divided by 2. And what do I get to two decimal places?
29.72.
And then if I look at the x, or the 27 minus, what do you get?
Negative 2.72.
And then I have to go through and I have to verify. So if I go to verify the first one, I get 2 times log base 3 of 29.72 minus log base 3 of 29.72 plus 3, which would be 32.72 minus 3. Is that going to work?
Yes.
Yeah, I can take the arguments of these values. If I look at the other one, I get 2 log base 3 of negative 2.72 and all of this other stuff, but this right here no longer matters. The minute I have that negative argument, it's not possible. So then my answer would be 29.72. So then the questions that I would like you to work on, 1, A, and C. converting to exponential format twice. So if I start off with log base 2 of log base x of 3x plus 4 equals 1, the first thing that I can do is with this log base 2 outside is I can rewrite it as 2 to the power of 1 equals log base x of 3x plus 4. And 2 to the power of 1 is 2. So then if I look at this again, I now have x to the power of 2 equals 3x plus 4 by using exponential forms again. What would I do at this point? I'm trying to solve for x, so what would I want to do?
Subtract 3x times 4 to the other side.
So move everything to the other side. And what does that create? What do we call this?
Quadratic equation.
A quadratic equation, and we solve quadratic equations by
Factoring.
or quadratic formula. So I check to see, can I factor this? Two numbers that multiply to -4 and add to -3.
Negative 4 and 1.
So then what are my two solutions? What could x equal?
4 or negative.
And then I want to check this. So if I check the first one, I would end up with log base 2 of log base 4 of 3 times 4, which is 12, and 12 plus 4 is
16.
So what is log base 4 of 16? In other words, 4 to the power of what equals 16? 2. So I get log base 2 of 2, which is equal to 1, which equals the right side. So that's been verified. And then if I look at the second one, when x equals -1, I get log base 2 of log base -1 of 3 times -1, which is
Negative 3.
and -3 plus 4, 1. Do I have a problem with this question? Negative base. So this is not possible. So this is an extraneous root, so x equals 4 becomes my solution. Okay, so I'm going to add question 7b.